In Russia, tests have been completed on a unique system for tracking satellites and other space objects, which radically strengthens the country's defense capabilities. There are only 4 such devices in the world, 3 in the United States and now 1 in our country. Why was it placed in Altai? What is special about the living glass of the telescope? And why do we hit satellites with a laser beam? We'll talk about this and the new rescue of the week after a brief summary of positive news. Another batch of self-propelled artillery units, Hyacinth-K, has been delivered to the troops. Russian scientists from Lebedev Physical Institute of the Russian Academy of Sciences have demonstrated a 70-qubit quantum computer based on an ion chain. At the Ural Locomotives plant, the welding of the bodies of the main motor car and the second non-motor car of the first Russian high-speed train has been completed. In Naberezhny Chelny, a bridge plant for KAMAZ trucks has been opened, as well as an electric motor production facility for UAVs in Saratov, the first Russian production of refractory metal components for the space industry, a gearless winch production facility in the Moscow region, a military field uniform production facility, a bucket-type hydro turbine production facility for small hydroelectric power plants in Dagestan, and a fish processing plant in Primorsky Krai. In Russia, the state trials of the mirror system for the new large telescope, which will become part of the Altai Experimental Laser Center named after German Titov, have been successfully completed. The tests lasted almost a year and confirmed that the images of space objects obtained with their help significantly surpassed all existing domestic counterparts in terms of detail. And this is a significant achievement, since there are only 3 complexes of this class operating in the world, and all of them belong to the United States: Advanced Electro-Optical System in Hawaii, Starfire, Optical Range in New Mexico, and SST in Australia. Now, after the launch into operation, which is scheduled for the coming months, another one will appear in Russia. The official data describes the new TI-3.12 telescope rather sparingly. The main mirror has a diameter of 3.12 meters, which is where the name comes from, and a mass of about 3 tons, as well as additional mirror optics. The device is capable of tracking space objects in near-Earth space at distances of up to 3,500 kilometers. In addition, the shape of the large main mirror can be changed during operation, and a laser rangefinder is built into the telescope's design. For an unprepared listener, this information may be hard to understand, but for specialists, it's pure music to their ears. And here's why. Creating a mirror with a diameter of more than 3 meters is a challenging task in itself, which requires about 5 years of meticulous work. But today, there are quite a few telescopes in the world with even larger mirrors, including one in Russia. However, comparing them to TI-3.12 and its American counterparts is like comparing a mining dump truck with big wheels to a racing car. Ordinary astronomical telescopes are designed to observe distant stars and galaxies, which move across the sky very slowly. Accordingly, the huge mirrors on Earth are also designed for very smooth movement, usually with a pointing speed of fractions of a degree per second. Now imagine an object passing by at an altitude of just a few hundred kilometers, moving at a speed of 1 degree per second, or even faster. To catch it and keep it in view, the telescope has to be incredibly fast and smart, and the main mirror together with its frame weighs almost 12 tons. And with the electric drive control system, it weighs 55 tons. Such a mechanism must move quickly and incredibly precisely, because even the slightest vibrations and oscillations blur the image. Anyone who has tried to photograph a moving object at a great distance with a smartphone knows how difficult it is to get a clear image. But that's not all the difficulties. Between the object and the camera is the Earth's atmosphere, with areas of different temperatures and densities. Even if the camera is fixed, the image of a distant object still shakes and shimmers, like hot air above a campfire. And to compensate for the distortions, a perfectly flat mirror must itself bend slightly in the right places and at the right time. How is this possible? The official release says that the shape of the large main mirror can be changed during operation, but the details are not disclosed. Often telescopes, such as the famous James Webb, are equipped with segmented mirrors made up of hexagons, each of which moves independently to create the desired geometry. But it is said that the TI-312 is monolithic and can still change its shape. Apparently, like its American counterpart, the advanced electro-optical system, it is equipped with special actuators. Dozens or even hundreds of these devices are located on the back side of the mirror, and on command, they press slightly on it in the right places, causing a controlled bending of the thin glass. Just a fraction of a micron is enough to compensate for distortions and provide a clear image. Thanks to this mechanism, the mirror is constantly breathing, like a living organism. And of course, this is very complex mathematics and a control system that in practice is available to only 2 countries in the world. Therefore, we can only congratulate the Latkarinski optical glass plant and the entire Russian holding company Schwabe on the successful completion of such a complex task. But that's not all. The TI-312 will be installed at the Altai Experimental Laser Center, which is an engineering marvel in itself. Construction began in 2004 in an extremely picturesque location near Lake Kolivanskoye, next to Mount Bolshaya, at an altitude of almost 700 meters, not due to the beauty of nature, but because of the climate. They searched for the location for 3 years. It is situated at the junction of the Siberian anticyclone and the dry winds from Kazakhstan, which allows for observations of outer space for 240 days a year. The facility operates equipment of the aerospace forces, which are part of the Strategic Space Surveillance System. Although it is publicly stated that TI-312 will monitor space debris, there is no doubt that it is capable of much more. Not only debris the size of a ping pong ball at an altitude of 200 kilometers, but also satellites and ballistic missiles. Moreover, it can not only detect them, but also study them in detail thanks to the high quality of the images it receives. And the laser rangefinder built into the telescope system allows it to calculate the distance to the objects being studied with an accuracy of a couple of centimeters. As you can probably guess, if an object is detected and classified as hostile, it can also become a target for precision weapon guidance. However, that's a different topic which is not usually discussed today: ammunition. This year, the TI-312 will be monitoring space debris, and there is no doubt that it is capable of identifying fragments. A ball at an altitude of 200, and it will also provide valuable scientific data because the TI-312 is needed by civilian specialists just as much as by the military. We will continue to follow this topic in future episodes. Next up is the educational recommendation, the announcement, and the rescue story.